Today we are doing factoring using the distributive property. We need a little review of greatest common factor for this, or the GCF. So if we have 45t and 30t squared, we can factor 45 into the lowest terms that it has, which is 5, 3, and 3. 5 times 3 is 15 times 3 would give us 45. T is a single term, so we can just leave that alone. And 30 can break up into 5, 3, and 2. T squared, we can break it up into t times t. So there we have our lowest terms. And now we see what they have in common. They each have a 5. They each have a 3. And they both have a t. So to find the greatest common factor, we multiply what they have in common together. So 5 times 3 is 15 times t. The greatest common factor of 45t and 30t squared would be 15t. So now we're going to use that in order to factor the equations completely. So for the first one, we have 15w minus 3v. 15 can factor into 3 times 5. W is just a single term, so we'll leave it. 3 is just 3, and v is v, so we can leave that. And see what they have in common. They both have a 3, so now we're going to be able to factor the 3 from each term. So the first, we're left with 5v. The second, we're left with a negative v. Now we can pull out the 3 from both terms, factor it into the front, and then combine what we have in the parentheses, which is 5w minus v. And there we have our factored terms. So for number 2, we have 7. U to the second can be factored into u times u, t squared to t times t. 21 can be factored into 3 times 7. U is a single term, so we can just leave that. T squared is t times t. And our third term, they're both single terms, u times t, so we can just leave that alone. And now we look to see what they have in common. So if you start with the smallest term, we have a u in each term, and we also have a t in each term. So we're going to be able to factor out a u and t from each term. So from our first term, we have a ut, our second term ut, and our third term ut. And what we have left in the first term is a 7ut. The second term, we have 21t. And our third, we have a negative 1. So now we can factor out the ut from all 3 terms, and then combine what is in the parentheses. So we have 7ut plus 21t minus 1, and we have our factored solution. Number 3, we have 15x plus 25x squared. 15 can break up into 3 times 5. X is a single term, so we can just leave it as is. 25 is 5 times 5. X squared is x times x. Look to see what they have in common. They both have a 5, and they both have an x, so we're going to be able to factor out a 5x from both terms. And what we have left in the first term is just a 3. And the second term, we have a 5x left. So now if we factor out 5x from the 2 terms and then combine what's in the parentheses, 3 plus 5x, we arrive at our final solution, 5x times 3 plus 5x. Number 4 you should do on your own, so pause the video. And you should reach the solution of 3xy times 4 plus 8y minus 10xy to the third. And make sure to show your work on this one. And now we're going to take the next step, factoring by grouping. When we're grouping these, we have 4 different terms. We're going to group them in twos. the first two terms and the second two terms. So we see what we can factor from the first term. We can factor out an n, and we're left with an r plus 5. And now we want to get our second term, the parenthesis, to be exactly the same as the first, so we can factor it out from both. And we have a negative r plus 5, so if we factor out a negative 1, we'd have a positive r and a positive 5, making the two parentheses the same, so now we can factor out an r plus 5 from both terms, and then combine what we have left, which would be the n minus 1, and the r plus 5 times n minus 1 is our factored term. So for number 6, we have 3np plus 15p as our first parentheses, negative 4n minus 20 as our second, and we can factor out a 3p from the first term and have n plus 5 left. And so we want our second term to be n plus 5. If we factor out a negative 4, that'll give us a positive n plus 5. Now we can factor out n plus 5 from both terms and combine what we have left of the 3p minus 4. And we reach our factored solution. And number 7, we have 2xy plus 7x as our first term, and a negative 2y plus minus 7 as our second term. The first term we can factor out an x, and we're left with 2y plus 7. The second term, they're both negatives, so if we factor out a negative 1, then we have our positive 2y plus 7. Now we can factor out the 2y plus 7 from both terms and combine what we have left of the x minus 1. And there's our solution. Number 8, I want you guys to try on your own, so pause the video and work it through. And you should get 3a minus 4 times 5 minus b as your solution. And again, make sure to show some of your work. So this is factoring by grouping yet, number 9. So we're going to group the first two and group the second two. We look to see what we can pull out of the first term, and we can factor out a c, and we're left with 1 minus 2d. And see what we can factor out of the second term to make the 1 minus 2d the same. If we look, we have a positive 1, and we want a positive 1, but the integer is a negative 4. So we're going to have to factor out a negative 4. And then we are left with negative 2d plus 1. However, this term isn't exactly the same as the first one, but if we switch it around, which we can do since it's adding, we can make the terms look exactly the same. So we can factor 1 minus 2d out from both terms, and then combine what we have left of c minus 4, and reach our factored solution. Now if we look at number 10, we're going to combine our first two terms and our second two terms again. And we can pull out a p from the first term, so we have 3 minus 2p. And we want to get a 3 integer, and we have 27, so if we factor out a 9, we have negative 2p plus 3. And again, we have to flip-flop these to make sure that they look exactly the same. So now we have 3 minus 2p in both terms, so we can factor it out and add what we have left, p plus 9, and we've reached our solution. So now we're going to go a little bit further and solve the equations that we just factored. The first one, we have 3n times n plus 2 equal to 0. To solve these, we're going to set each term that we have equal to 0. We have 3n equals 0, or n plus 2 equals 0. We're going to solve the first one for n by dividing by 3. n equals 0 is one of our solutions. Subtract 2 from both sides. N equals negative 2 is our second solution. And now we can check these by plugging in both of our solutions to our original 3n n plus 2 and making sure that it's equal to 0. So if we start with our first term of 0, we have 3 times 0, 0 plus 2. 0 times 2 would give us 0, so 0, the solution holds up. Plug in negative 2. We have 3 times negative 2 plus 2. So we have negative 6 times 0 would give us 0, so negative 2 solution also holds up. And move on to number 11. You guys should do this on your own. It's similar to the first one. Set each of these terms equal to 0. X minus 2 equals 0. 4x minus 1 equals 0. Solve for x and check your solutions. You should reach x equals 2 or x equals 1/4. And it's important to check your solutions because sometimes they don't work out. And number 12, we have 8b squared minus 40b. It's not factored, so we're going to have to. We have 8b. We can factor out from both terms. We're left with a b minus 5. We can set each of them equal to 0. 8b equals 0, or b minus 5 equals 0. Solve the first equation for b by dividing by 8. We have b equals 0 as one of our solutions. Or add 5 to the second one. b equals 5 is another solution. And you should check this one as well. And our last one, x squared minus equals negative 10x. Notice there's no equals 0. We need the equals 0. So if we move one term to the other side, so by adding 10x, now we have an equal to 0, and we can factor that by pulling out an x from each term. So we have x plus 10, and that's equal to 0, so we can set each term equal to 0 now. X equals 0, or x plus 10 equals 0. The first term is already solved, so the second term we just subtract our 10. X equals negative 10 is our second solution. And now 14. The hop of a kangaroo can be modeled by h equals 24t minus 16t squared, where h is the height of the hop and t is the time in seconds. So we're going to find the values of t when we're given h equals 0. So in our equation, we're plugging in 0 for h. So 0 equals 24t minus 16t squared. And now we're going to have to factor this so we can solve. We can pull out an 8t from both terms. And we have 3 minus 2t left. And set each of them equal to 0. We have 8t equals 0. Or 3 minus 2t equals 0. And we'll solve them each for t, so the first term divide by 8. We have t equals 0 seconds, or 3, add 2t to the other side would make it positive. 3 equals 2t. Divide by 2 to solve for t. 3 over 2 seconds equals t is our second solution. So we have two solutions for this, and you can check it to make sure that they both work out. And that's the lesson for today.